So this next question says two functions f of x and g of x are defined as follows. For x is a real number and x greater than 0. Okay, so x greater than 0 meaning that this always works out. Okay, we wouldn't be able to get a square root if it wasn't greater than 0. Well, greater than or equal to 0. Use these functions here to answer parts B, 1, 2 and 3. Now part 3 is more to do with functions. Okay, so we won't focus in on it too much until we do functions as a chapter. Okay, but parts 1 and 2 are things that we can do. Okay, so the first one tells me that f of x is e to the power of 9 by x. Okay, and then the question asks for f of 1.2. Okay, so all that is telling me is it has replaced out the x with the 1.2. Okay, so from there to my next step, that is all I am seeing is that x is 1.2. They have told me that by putting it inside the brackets. Okay, so here all I need to do is solve this when x is 1.2. So it's e to the power of 9 times 1.2. Okay, at that point, what can I do next? Well, e is not a variable, it's a constant. Okay, so I can actually type this all into my calculator because there is no variables involved. Okay, so it's e to the power of 10.8 when we multiply that out. Okay, so literally type into your calculator e to the power of 10.8. Okay, and I get 49020.8. Okay, so they've said correct to one decimal place, but they actually said give your answer in the form a by 10 to the power of n, where a is a real number between 1 and 10, n is a natural number. Okay, and so what they actually are looking for me to do is write this in scientific notation. Okay, so remember my scientific notation. Okay, I need it to be written as a by 10 to something. Okay, and a is a number between 1 and 10. So how could I change this to be a number between 1 and 10? I have to move the decimal point somehow to being here. Okay, after the 4, before the 9. So I would have to move the decimal place 1, 2, 3, 4 places to the left. Okay, so if I wanted to write this as a number between 1 and 10, I would be writing it as 4.90208. Okay, but I have then moved the decimal place 4 places to the left. So I say by 10 to the power of, and then however many places to the left you moved it is what you put as the power on the 10. Okay, so I have moved it 4 places to the left, so that power is 4. Okay, so give your answer in scientific notation to correct to one decimal place. So initially I actually wrote a correct to one decimal place, but here there is a new decimal place. Okay, so correct to one decimal place from this one is going to be 4.9 by 10 to the power of 4 is my final answer there. Okay, the next part then says find the value of x for which g of x is equal to 3.5. Okay, so again, I'm just going to write down, so what was g of x? So g of x was my natural log ln times the square root of x. Okay, so they have now told me that g of x is equal to 3.5. So g of x is this and g of x is this. So those two must be equal to each other. Okay, so if they're both equal to g of x, okay, if they were both equal to 2, then they would also be equal to each other. Or if they were both equal to 3.5, okay, then they were both equal to each other. So if you want to think about this as like a subbing in question, then you can now sub in g of x as 3.5. Okay, so 3.5 is my natural log of the square root of x. Okay, now they want me to find x. I need to somehow get towards getting x. Okay, There's a square root, but that's kind of like inside a bracket almost of what the natural log is acting on. So the natural log is acting on this full thing, the square root of x. So I can't get rid of the square root by just squaring across, because I don't really get natural logs squared. Okay, I want to try and get rid of this natural log first. So how could I rearrange it to get this square root x on a side by itself? Okay, now if you haven't watched our other videos yet on what the natural log is, then this might be a little bit difficult, okay? But we are going to try and use what we know the natural log is, and we're going to use our log rule that allows us to rearrange. So what is the natural log? How could I rewrite that to help me rearrange this? Okay, well, my natural log is a log with a base e. Okay, so how could I rearrange this so that the square root x was on a side by itself? Okay, well, look at it. Look at our rule. Okay, it was to write it like this. It's a, so the original log, the original base on the log, so the e, okay, to the power of x, so what it was all equal to before, so to the power of 3.5 is equal to, and then y, so the number that came after the log there, so is equal to the square root of x. Okay, so that there was our key thing with the natural logs, recognizing that to get rid of a natural log, okay, it's e to the power of whatever is on the other side to get rid of it. Okay, so there, yeah. Okay, so now what do we do? Okay, at this point now we're just back to our indice work or our surd work, okay, because we're getting rid of a square root. How do I get rid of a square root? I have to square. Okay, so what is e to the power of 3.5 all raised to the power of 2? Okay, what is that equal to? Because as soon as I know what that is equal to, then I have x. Okay, so open up your indice rules. You already have them open actually because you have your log rules open and they're on the same page. Okay, if I have a to the power of p all to the power of q, then this is my rule. Okay, so they multiply together, so it's going to be e to the power of 3.5 by 2, so to the power of 7 is equal to x. Okay, I could type that into my calculator, and my calculator would give me back a decimal, which I don't want, because then I would have to round it by writing down the answer, because it's a decimal that continues on forever. Okay, so I don't want to write down a decimal, because then I'll have to round my answer, so I want to leave it like that. And actually, if I go back and look at the question here, they actually told me give your answer in the form e to the power of p. So that is my answer there for x, in the form e to the power of something, where p is a real number. Okay, so that's that question done out there.